Hello friends, I, BHATIA, welcome you to my YouTube channel Maths DNA from Origin to Infinity. In this video, we are going to discuss a question of operation research from the examination of Csir-Net Mathematics. But before that, let me share something with you. We believe that to qualify 4 different examinations, all you need is just one single book, all-in-one book with 2000 plus solved questions. For this, you can register at our WhatsApp number given below. Moving on to the question. The question is, consider the following maximization problem. The problem is, maximize x1 plus 3x2. Subject to constraints, first x1 plus x2 less than equals to 6. Second, 2x1 plus x2 less than equals to 8. And the third one, x1 plus 2x2 less than equals to 9. With non-negative conditions, x1 greater than equals to 0 and x2 greater than equals to 0. Then which of the following is the dual problem? The options are A. Minimize 6y1 plus 8y2 plus 9y3 subject to constraints. First one, y1 plus 2y2 plus y3 greater than equals to 1 and y1 plus y2 plus 2y3 greater than equals to 3 with non-negative conditions y1, y2 and y3 greater than equals to 0. Option B, same as option A, but in the constraints, the first constraint is now greater than equals to 3 and second is greater than equals to 1. Option C, the inequality is changed. The first constraint has less than equals to 1 and the second have less than equals to 3. Other all the conditions are same. And now in option D, the coefficients of the minimized problem are changed. Firstly they were 6, 8, 9, now they are 9, 8, 6, whereas the constraint are same as option A. Let us solve this question. This was the most easiest question from the paper. How do we solve this? Let us see. It is given to us that maximize x1 plus 3x2 and the constraints are x1 plus x2 less than equals to 6, 2x1 plus x2 less than equals to 8 and x1 plus 2x2 less than equals to 9 with two non-negative conditions. And we have to make the dual of this problem. So whenever you are given maximum, to make the dual you need to convert the maximum to minimum. So the dual will be firstly minimize. Now the variables given on the right hand side of the inequality of the constraint, that is 6, 8, 9, become the new coefficients with our new variables y1, y2 and y3. So that is 6y1, 8y2 and 9y3. Basically you multiply y1 with the first element, that is x1, 2x1 and again x1 over there. The numbers given to the less than equals to inequality, and the constraint will be first y1 plus 2y2 plus y3, that is you multiply element y1 with first, second and third equation and then take the coefficients with coefficient of x1, that is 1 to 1, and that will be greater than equals to the coefficient of x1 in our given question, that is maximize x1 is having coefficient 1. So y1 plus 2y2 plus y3 will be greater than equals to 1. Similarly for x2, take the coefficient of x2 from first equation, that is 1, so 1y1, coefficient of x2 from the second equation 1y2 plus coefficient of x2 from the third equation 2y3 will be again greater than equals to 3. The inequality changes. In the given question it was less than equals to, in our answer it will be greater than equals to, and the right hand side coefficient will be the coefficient of our given maximization problem with variable x1 and x2, and the non-negative conditions y1, y2 and y3 greater than equals to 0, which is option A. Thus the correct answer is option A. Thank you, and you can be a member of our social club and watch 520 plus videos on our YouTube channel and get a complete study material for any higher mathematics competitive exam from our WhatsApp group.